In the last lecture, we solved the length, or we expressed the length in terms of r, which is the radius of the atom in the unit cell. And we have one more left, the face-centered unit cell. It's a little bit easier. Once again, we are looking for a stretch where all of the atoms are connected without gaps. So C would be the diagonal through the face, would be the ideal length to pick. Again, that it would be equivalent to 4r, and we use the Pythagorean theorem to then, c squared equals L squared plus L squared. That's why it's easier, because we now have L and L instead of two other variables. All we have to do is substitute C in terms of R, which we can easily do as I've already shown here. So we get a 4R squared. If I put that together, that's 2L squared. And now we simply bring L on the left side and divide by 2. So we get 4R, don't forget this is in parentheses, divided by 2. Now we take the square root of both sides, and we end up with, put it down here, L equals 4R divided by the square root of 2. And then most of the time we don't like to divide by square roots, so what you can do is you can multiply both sides by the square root of 2 here, which does the square root of 2 times the square root of 2 equals then 2. So we get a number. We prefer that, and this is how you bring that square root up. And so L is then equal to, going to rearrange it, and also 4 divided by 2 is then 2. So it's 2 times the square root of 2 times R. So now we know that L equals 2 times the square root of 2 times R. So that is the length expressed in R. And of course this is just a number, but we leave it like that so that we can have infinite number of significant figures. So this next slide, this slide is just clean math again, what I just calculated. And this is the summary slide of the 3 cubic unit cells that we will be dealing with on the exam and in this chapter. Simple cubic, body-centered, and face-centered. Know the difference. And you can use this chart to look up the coordination number and the cell content, how many atoms are in the cell, and of course the length expressed in terms of R. We just did this one, and in the previous lecture we did that one, and the easy one was the simple face centered, where L is just equal to 2R. So that's pretty simple. So let's work on application. So on an exam I may give you a problem like this. Given platinum face-centered cubic unit cell, R is equal to 139 picometers. Find the length and the density. Okay, so you have to think about this one for a bit, right? The one thing you can definitely easily do is find the length, because we do know the relationship between the radius and the length, given that we have a face-centered cubic unit cell. So going back to that cubic face-centered unit cell, we know that L is going to be equal to 2 times the square root of 2 times R. So that's easy. So we know that the length is going to be equal to 2 times the square root of 2 times R, which is 139 picometers. All right, so the square root of 2 times 2 is equal to 2.83, and if 2.83 times 139 picometers then equals 393 picometers, which makes sense. It's roughly 2.5 times or so, right? So that's the length of one of the cube's sides. Okay, so that would be, one of these is 393 picometers. So this one we solved. What about density? All right, so density is equal to the mass of a substance divided by the volume. Okay, well, we can determine the volume of the cube by simply saying the volume is equal to the cube length cubed, right, to the third power. And density is usually expressed in, or the units of density are grams per milliliter, and a milliliter is a cubic centimeter. So we do want to convert the picometers to centimeters. So there's 10 to the minus 10 centimeters in a picometer. So we do times 10 to the minus 10 centimeters per picometer. That gives you the length in picometers, which is 3.93 times 10 to the minus 8 centimeters, right? You just simply move this over. This would be 3.93 times 10 to the 2, and then 10 to the 2 times 10 to the minus 10 equals 10 to the 8. Of course, we want to know the volume, so we have to do 3.93 times 10 to the minus 8. We want to cube that, and you can do this in the calculator pretty easily, and so that gives you a volume of 6.08 times 10 to the minus 23 centimeters cubed. That's the volume, right? That goes here. What about the mass? Well, we know it's platinum, so we have the molar mass, and so we know the molar mass would be, and so if you look that up on the periodic table, that is 195.09 grams per mole, right? And so if you remember, the mole is exactly 6.02 times 10 to the 23 atoms, right? So that's our conversion factor. But we also know how many atoms are in one of those unit cells that has this volume. We know there's exactly 4. We get that from the table. That is the unit cell content. So we know we have 4 atoms. And if we want to know the mass of these 4 atoms, we first multiply by Avogadro's number. So actually you have to do 1 mole divided by 6.02 times 10 to the 23 atoms, right? I know this because I'm canceling units. I said multiply, but I knew instantly it's incorrect because I'm writing my units, so you need to really write your units. Now I can use this conversion factor to figure out how many grams there are in 4 atoms, or 4 atoms. What is the mass of 4 atoms? So I do 195.09 grams per mole of platinum, and then gives me a mass of 1.296 grams times 10 to the minus 21. Sorry, it's 1.296 times 10 to the minus 21 grams, and that goes up here. And so my density, when I crank it out, is 21.3 grams per centimeters cubed. So I suggest that you work a couple of these problems, you kind of think it through, rework this one on your own, maybe even right now pause and work it out. Here it is, all worked out, every step, so you can see it. It's in the handouts. Let's do one more and then that'll wrap up the chapter. Alright, let's work one last problem. It should be much easier than the one we just worked because it's very similar. Except it has a slightly different angle here. Now I'm given a face-centered cubic unit cell, so that's the same one we just dealt with. So we know we have 4 atoms per unit cell. We also know that the length in terms of r is going to be 2 times the square root of 2 times r. That probably will become important, and in this case we don't have platinum, we have rhodium, and rhodium has a molar mass of 102 grams per mole. This is the information that we needed to solve the last problem. I'm assuming we're going to need to know one or all 3 of these again, right? So this time I am given the density and I'm told to solve for the radius, okay? So the first thing we can do is we take that density which is mass over volume, and we can determine the mass the same way we did before, because we have 4 atoms, and we know that 1 mole of rhodium would have 6.02 times 10 to the 23 atoms. That's how many moles 4 atoms would be, and then we multiply by 102 grams of rhodium for every 1 mole of rhodium. And atoms cancel, units are in grams of rhodium, and so the mass of that would be 6.83 times 10 to the negative 22 grams. That would be the mass of 4 atoms. I know the density, so this time I'm going to solve for volume. Volume is going to be equal to the mass, which is that 6.83 times 10 to the minus 22 grams, divided by the density, which is 12.41 grams per centimeter cubed. That gives me a volume of 5.51 times 10 to the minus 23 centimeters cubed. If I take the cube root out of that, I get to the length, which is what we need. So the length of one of those is going to be 3.8 times 10 to the minus 8 centimeters. So that would be, again, I'm going to draw the cube up here. That would, this is the volume. If you take the cube root out of it, you just take that number to the 3rd power, in case you didn't know, on your calculator. And you can, this is then of course the length of 1, but we want to know the radius, and so now we need to finally use this formula here. So L is equal to 2 times the square root of 2 times R, which is 3.8. Sorry, we have to solve for R. I'm getting a little tired, but obviously we have to take this equation. This is L, and we need to solve for R. It's pretty easy, really. You take R is equal to L divided by 2 times the square root of 2, so 3.8 times 10 to the minus 8 centimeters divided by 2 times the square root of 2. And if you also convert that to picometers, which is what unit radii are usually, atom radii are usually reported as, if you convert that to, so there's 1 picometer equal to 10 to the minus 10 centimeters, and you crank out this number, then that gives you a radius of 135 picometers. So the radius of rhodium is 135 picometers. All right, that's enough for the day and the chapter.